everyone, welcome to Introduction to Programming with Python. This is lecture 9. In this lecture, I'm talking about tuples and modules, although we have talked a little bit about modules earlier, but we will elaborate a little bit more on that. Tuples is another data type in Python, and it's defined as an ordered immutable sequence of objects. It's basically an iterable so that you can store more than one values in a single object, in a single variable, as we'll see. So that's what a tuple is. It's a collection of Python objects separated by commas. That's the syntax. It's immutable because once an element is inside a tuple, it cannot be reassigned. You can change the entire tuple, but not a specific part of it. The way we define tuples is using parentheses, as we will see just now in Spider. Before we actually go and create tuples, we should know why we are using them. The basic idea behind tuples is that they can be used for multiple assignments, so that I create a single object and I can assign it to multiple variables all in a single line of code. Let's check in Python. Let me create an empty tuple to make it clear how to create a tuple. So this is the parentheses that should be used to create a tuple, and let me just say print. I already said empty tuple is the name of the object that I created, right? I get this, and let's also check the type of this empty tuple. The type should be tuple, as you can see here. Now obviously I did not create a tuple to have it empty. I can put values in it. Before we actually start putting values in any tuple, I would or maybe let's begin with assigning or giving values, and then I would talk about immutability. Let me create another tuple. I'm naming it as tuple1, and I'm saying it has two values, Python and maybe programming. Let me create this. Now you can see I'm doing a multiple assignment to a single variable. Let's see if it throws an error or not. It did not throw an error. Why? Because what I just created is nothing but a tuple. A tuple can save multiple values altogether, right? As you can see, I can create multiple values in a single object. This is a tuple. Let me go and create another tuple and show how we can concatenate the values in a tuple, and also demonstrate that I can have different value types in the elements that I'm creating. What I mean by that is I'm creating tuple1. I'm just naming, you can name it anything just like variables, and this holds 1, 2, 3, 4, 5. So as you can see, these are integer values. And then let me create another tuple. I'm naming it as tuple2 and assigning it string values, which is a comma b comma c. You can also have mixed tuples, as I'll show you in a short while. Let me create tuple1 and tuple2 first. So they are created. Tuple3 is going to be a concatenation of tuple1 and tuple2. You can do that in multiple ways. I'll show you two of them. So I'm saying tuple1 plus tuple2. We have seen this concatenation operator before. And let me see what this does. Let me go and print tuple3, because this is the concatenation of two already existing tuples, right? So all of them got concatenated and I came up with this new tuple3. Similarly, I can create nesting or nested tuples within tuples, and that's done by simply, again, we can take the same example, or let me create tuple4. What it does is, this is another way of creating a tuple, right? I'm creating a tuple again, but the elements inside this are also tuples, right? So they are tuple1, tuple2, and also tuple3, right? Let me go and create that, and then go and print tuple4. So these are two ways of concatenating different tuples, right? As you can see, the elements are tuples themselves. That's why this is called nested tuples. So basically we have a tuple4 that has elements that are tuples themselves, and we'll come to these tuples nested tuples later on in the course, but for now it's sufficient to know that this is how you can concatenate, this is how you can create nested tuples. Now moving on to replication in tuples. Let me comment that as well so that we remember. Replication in tuples. For example, I have tuple 5 and it's an existing, or I'm just creating a tuple 5 that holds a string rpics, and then let's say I have to multiply it by 4, and this is nothing but, we have seen this before, this is replication. Let's see what happens if we are trying to replicate a tuple, right? And then say tuple 5, right? I want to see what's inside tuple 5. You can see that there was just one element and all of them got concatenated and repeated 4 times. Now the question arises, what happens if I had 2 values instead, right? I can have 2 or more values. Let's say I have Python and hello and also some integer, and this is also giving you an example of having mixed data types in a single tuple. Let's see what happens now, right? I did not get an error, so that means it worked. Let's see. Now if I scroll back and show you what happened, is that I'm getting, or maybe I should have repeated it twice so that it becomes clear what exactly happened. Now it is clear, right? Obviously this entire tuple is getting repeated twice. All the elements get repeated twice. That's what's happening when we are trying to replicate a tuple. Just, this is quite similar to a string actually. This is what we did in a string as well. Okay, now there is a function called len that we've used multiple times and we'll be using here again to check the length of different tuples. The len function returns the number of elements in a tuple. Let me make it clear what this means by checking the length of different tuples that we've created so far. Let me check the length of tuple 5. I'm guessing it should be 1, 2, 3, 4, 5, 6, 12. So there are 12 elements. It should return 12. Let's see. Yes. Now let's check the length of tuple 4, because that's an interesting one. It has tuple, it's nested, right? Now as you can see, let's go and check what tuple 4 was to make things clear. It's returning the number of elements in tuple 4. So it does not care what the nested tuples have in return, right? We'll have to use some other methods to know that, but for now it's returning the number of elements in tuple 4. Okay. Next important function that we use with any iterable, again I'm repeating, an iterable is something that has more than one value, is indexing and slicing. What is indexing? Indexing is a way of getting access to a certain element in a given iterable. For example, in our case it's a tuple. Let me create a tuple underscore new and give it new values, obviously some random numbers or anything that you like, and then this is created here, right? Now I want to access the value 8. Now going back to our strings lecture, we remember that there is a position to every value in an iterable, and the way the position starts is it starts counting from 0. So this is 0th position, this is first, this is second, third, and so on. Now I need to access 8, which is according to my indexing reasoning at position 0, 1, 2, right? The way I'll index it is by simply doing tuple underscore new and then square brackets 2. This is how I get tuple new. Very similar to what we did with strings, right? Similarly, you can do slicing just like we did with strings. Let's say I want to return the like certain elements starting from number 7 and going up to maybe number 1. So 1, 2, 3, and so this is up to 3. But remember, it counts 1 less, right? The way this is structured, any slicing operator is structured, is that you'll have the variable, which is in our case tuple new, right? And then the square braces, it is start, stop, step. This is just a reminder from the strings lecture, right? And let's see what we get here. And by default, the step is 1. We know that, right? I can change the step to anything. And also one reminder again, to get only the last value, I can simply go ahead and do a -1. Because if we start counting from the back, this is -1, -2, -3, and so on. Let's do this. Okay, so the last element is 0, and obviously that's what we get, right? Now, a couple of important methods that are used with tuples before we move on to our modules part of the lecture is that I know I've created this tuple underscore new, and just like with strings, there are certain methods that are associated with this. So a few of them that we'll be covering in this course are count and index. Okay, so let's see what count does. And in fact, I should have created, okay, we can do this. So that dot count, and then give the element that you want to count, how many times it appears in this. So ideally speaking, it should be 1, but I could go and create 999 explicitly, and then ask dot count to count this, and obviously I should get 3. So that's the first method. The other method is the index method. We are trying to index, or we are trying to find the index of a certain element, and let's say I'm trying to find the index of 8. We know that the index of 8 is 2 because we start counting from 0, right? 2 is at the 0th position, 7 is at the first position, and 8 is at the second position. Now what happens if I say dot index 9, because I have 3 9s? Now this returns 5, which is the value of the first 9. So if you're having multiple values, the index that will be returned by the dot index method is going to be the first occurrence of that element. So make sure you remember that. Okay, so this was about tuples. Moving on to our module part. Why we are talking about modules is because we care about modular programming. We don't want to repeat ourselves. Some of the advantages of modularizing code are simplicity, maintainability, and I personally believe it's reusability, which is why we create modules. Now going back to our previous lecture, we talked about creating a module that would calculate the area of almost all geometric objects, right? We know how to write functions. So in this part, what I've done is I've created functions. This is a function. We know how to define a function using the keyword def. So I've created a function for a circle, for a cylinder, and a sphere, all in a single file. I named these functions something, right? So this is something that we've seen before, so I'm not repeating it. And I will save it with some name. Let's say I save it as area dot py. Okay, so there is an existing file. I would just name it area1.py. That's also fine, right? And then execute it. By executing, okay, so this got executed, right? I did not have any print statements here, so obviously there was no output, but I did not get any error that indicates that I executed my file correctly. Now, the advantage of keeping all these functions together in a single file is that I can now use this area1. I can call it and call the functions that are here. Let me show you what I mean. All I have to do is I'm importing my own module now. What I did was I bundled together these functions, and now I have my own module, and I know the name of the module is area1.py, right? So let me say import area1, right? And I think it has to be in our working directory. That's important. So check that this area.1 is saved in your working directory, which is this directory up here, right? Now I have this area1. I can simply go and call the functions in it. For example, I'll show you what I mean. Area1 dot. So the moment I hit dot, I get the names of all the functions I created. So remember, the functions that I created were def circle, then cylinder, then sphere. Let's say I'm interested in calculating the area of the circle, right? So I can simply say circle, and then in parentheses it takes the radius, right? And then it returns the area of a circle. Let me do that. So what is the area of a circle that has radius 5? Let me go and run this, right? So this is the value that I get. Similarly, I can call other functions that are there in my module. I can go and create a bigger module with more functions in there. So this was only to demonstrate that this is how modules work in Python. For this lecture, I think I'm done with tuples and modules. See you in the next lecture where I talk about images. Thank you.